Talking Trees with Lily and Jad. Welcome to this episode. Today we're exploring the fascinating processes that drive the water cycle in nature. We'll start with transpiration, examining how plants absorb water and release it through tiny pores in their leaves, and the factors that impact this process. Next, we'll dive into interception, the way leaves and branches capture rainfall, affecting how much water reaches the soil. Finally, we'll discuss evaporation from water surfaces, both on a small scale and in the broader context of the water cycle. Let's uncover how each of these processes contributes to our environment.
Welcome back to the Deep Dive. Today we're going on a journey to explore the world of trees and their amazing water management secrets. I know what you might be thinking. Water management. Trees. They just kind of stand there, right?
That's what it looks like from the outside.
Sure.
But beneath the surface, there's a whole lot going on, a bustling hub of activity, especially when it comes to water.
So tell me, what's the first thing we need to know about water and trees? What's the key process here?
Well, it all starts with something called transpiration.
Transpiration. Okay, that sounds complicated.
Not at all. It's pretty simple, actually, when you break it down. Imagine a tree as a giant straw.
Okay, I can picture that.
So the roots, at the bottom of the tree, they act like the bottom of the straw, sucking up water from the soil.
Okay, makes sense.
And then this water travels upwards through a special tissue called xylem. It's kind of like the inside of our straw.
So the water is moving up against gravity.
Exactly. And that's where things get really interesting. This is where the magic happens. It's all thanks to two forces, cohesion and tension.
Cohesion and tension.
Yeah. See, water molecules, they're like tiny little magnets. They love to stick together, right?
Yeah.
That's cohesion. And they also like to cling to the walls of the xylem. So you've got this continuous chain of water molecules all clinging together and being pulled upwards.
From the roots to the leaves.
Exactly.
Okay, so the water is like in a chain, being pulled upwards. What's doing the pulling?
That's where the tension comes in, as water evaporates from the leaves. Up at the top of the tree, it creates this kind of suction, this pulling force that draws more water up through the xylem.
Okay.
It's like when you use a straw to drink your favorite juice. You create suction at the top, and that pulls the liquid up the straw.
Okay, I get it. So the water's traveling up the tree
Yeah.
to the leaves, and then what?
Then we get to the grand finale. The leaves have these tiny pores called stomata. They're like tiny little mouths that can open and close.
Stomata.
Yeah. And when the stomata are open, well, water vapor escapes from the leaves into the atmosphere.
And that's dot evaporation, like when a puddle dries up on a hot day.
You got it. Evaporation is just water changing from a liquid to a gas. And it's a key part of the water cycle. In the case of trees, evaporation is the final act of transpiration.
Wow. So transpiration is this whole journey of water moving through the trees, starting at the roots and ending with evaporation from the leaves.
Exactly.
But is it risky for trees to be losing so much water, especially on a hot day? I mean, I get thirsty just thinking about it.
Well, trees have a clever way of dealing with that. It's all about balance. Remember those stomata we talked about, those tiny mouths on the leaves?
Yeah.
Well, they can open and close to regulate how much water is lost. When it's hot and dry, the stomata close up to conserve water.
So it's like trees have their own built-in air conditioning system.
You could say that. Transpiration helps cool the leaves down, prevents them from overheating. It's similar to how sweating helps us cool down.
Amazing.
It is. And here's a cool fact. You ready for this?
I'm ready. Hit me.
A large oak tree can transpire enough water in a year to fill an entire swimming pool. Seriously. That is a lot of water. But wouldn't all that water loss be a problem if there's a drought?
Yeah, that's a great question. And you're right. Drought can be a real challenge for trees. But they have some pretty clever ways to cope.
Oh, like what?
Well, one way is by closing their stomata to reduce water loss, like we just talked about. Another way is by shedding leaves to decrease their overall surface area.
So they basically downsize to conserve water.
Exactly. But if the drought is really, really severe and the tree just can't get enough water, that's when things can get tricky.
What happens then?
Well, if a tree loses too much water and it can't replace it, air bubbles can form in the xylem, and that disrupts the flow of water.
Uh-oh.
Yeah, it's not good. It's called cavitation, and it's basically like a traffic jam. in the tree's water transportation system.
So, like, everything gets backed up.
Right. And it can weaken the tree, make it more susceptible to diseases
Yeah.
and pests.
So transpiration is essential for trees.
Absolutely.
But it also makes them vulnerable if there's not enough water. It's a delicate balance.
Wow. So we've covered transpiration and evaporation. Two key processes in how trees manage water. But I remember you mentioning a third process at the very beginning, interception. What's that all about?
Ah, yes, interception. Think about what happens when it rains in a forest. Some of that rainwater never even reaches the ground because it gets intercepted by the tree canopy.
By the leaves and branches. So it's like the trees are acting as giant umbrellas.
You could say that, but doesn't that mean less water is available for the trees themselves?
Yeah, that's what I was thinking.
Well, that's a great question. And it leads us to some really interesting trade-offs.
Yeah, it's true. That interception can reduce the amount of water reaching the soil directly. But it's not all bad. It actually plays a super important role in protecting the forest floor from erosion. See all those raindrops?
Yeah.
If they hit the ground directly with full force, they could wash away the topsoil.
Oh, I see. So the trees act as a buffer. They slow down the rain and give it a chance to soak in gently. Plus, that intercepted water, it doesn't just disappear. It eventually drips down from the leaves and branches, nourishing the plants below.
So it's like a slow release watering system.
Exactly. And some of that intercepted water, it evaporates back into the atmosphere. So it's still contributing to the water cycle.
Wow, it's amazing how something as simple as rain hitting leaves can have such a big impact on the whole ecosystem.
It really is. And you know, the amount of water intercepted can vary quite a bit depending on the type of tree and even the type of precipitation.
Oh, interesting. Tell me more.
Well, for example, conifer trees with their needle-like leaves, they can hold on to more water than broadleaf trees.
That makes sense. It's like if you compare a dense pine forest to, say, a grove of maple trees. Those pine needles create a much thicker canopy.
Right. And think about snow. Conifers, with their needles all year round, they can intercept a lot of snow. And then it melts gradually, providing this nice slow release of water into the soil.
It's like a natural irrigation system.
Exactly. It's incredible, isn't it, how trees have adapted to make the most of the water that's available to them.
It really is. And speaking of adaptations, we've been focusing a lot on forests. But what about trees in other environments, like, say, a cactus in the desert? I mean, they must have some serious water-saving tricks up their sleeves.
Oh, absolutely. They've evolved some pretty remarkable strategies to survive in those harsh, dry conditions. Think about those iconic spines, for example.
The spines, I always thought they were just for protection.
Well, they are, of course, but they do so much more. They actually help reduce water loss by creating a layer of still air close to the plant's surface, so there's less evaporation. Plus, those spines provide some much-needed shade.
Wow. Multi-purpose spines. And what about their roots? I've heard that cacti have really shallow roots. Is that part of their water-saving strategy too?
Exactly. Those shallow roots allow them to quickly absorb any rainfall before it has a chance to evaporate in the desert heat. And to top it off, they have thick, waxy cuticles on their stems to further reduce water loss.
It's like every part of a cactus is designed to conserve water. They really are masters of survival.
They are. It's a testament to the power of adaptation. And it's not just cacti. Trees and rainforests, for example, they face a whole different set of challenges.
Oh, right, because they have all that rain.
Yeah, but they also have to compete for sunlight. So they often have these large, broad leaves to capture as much light as possible for photosynthesis.
Right, for making food.
Exactly. But those big leaves, they can also lead to increased water loss through transpiration. Remember,
more surface area means more water loss.
Exactly. So how do they balance that need for sunlight with the risk of losing too much water?
Good question.
Well, many rainforest trees have developed these pointed tips at the end of their leaves called drip tips.
Drip tip.
Yeah, and these drip tips allow water to drain off the leaf quickly, so it doesn't just sit there and evaporate.
That's so cool, like little gutters for the leaves. So it sounds like whether it's a cactus in the desert or a towering tree in a rainforest, every species has evolved its own unique way of managing water.
Precisely. And these adaptations are so important for their survival, especially as we face a changing climate with more droughts and less predictable rainfall.
Right, because we were talking earlier about how transpiration can make trees vulnerable during droughts. I'm wondering, how is climate change impacting all of this?
That's a great question. And it's something scientists are studying very closely. As temperatures rise, the rate of evaporation increases, leading to drier soils, and that puts even more stress on trees.
It sounds like we're making an already tough situation even tougher.
Yeah, I'm afraid so. And you know how we talked about cavitation, that traffic jam in the water transport system? Well, climate change could make that a lot more common.
Because of the increased drought stress?
Exactly. And when trees are weakened by drought and cavitation, they become less efficient at absorbing carbon dioxide from the atmosphere.
And that's a big problem, right? Because forests are supposed to help us fight climate change.
They are. Forests act as giant carbon sinks, helping to regulate the planet's temperature. But if they're struggling to survive, they can't do their job as effectively.
It sounds like a vicious cycle. Climate change leads to more droughts, which stresses trees, making them less effective at absorbing carbon, which further exacerbates climate change.
Exactly. It's a worrying trend. And I think it's also important to remember that trees are not just passive victims in the face of climate change. I mean, they've been adapting and evolving for millions of years.
That's right. We've seen some amazing examples of that, like those cacti spines and the drip tips on rainforest leaves. Nature is pretty incredible when it comes to finding solutions.
It really is. And I think by studying these adaptations and doing what we can to help trees survive, we can learn some valuable lessons about resilience and sustainability.
Well said.
And, as we wrap up today's deep dive, I'm left with a sense of hope. Because I think if we understand these processes and we take action, we can help ensure that trees, these majestic giants, they continue to thrive. They can keep providing us with clean air, fresh water, and a stable climate for generations to come.
I love that. And to all our listeners out there, here's something to think about as you go about your day. If you were designing a forest to maximize water conservation in a changing climate, what kinds of trees would you plant and why? Until next time, keep exploring, stay curious, and let's all do our part to protect these incredible trees.
Thanks for tuning in. We hope you enjoyed today's deep dive into the water cycle and the vital roles that plants and trees play in it. If you enjoyed this episode, don't forget to share with anyone curious about the hidden workings of our natural world. Join us next time as we continue exploring the fascinating world of trees and arboriculture. Until then, keep learning and keep appreciating the wonders around us.